Good day and welcome to the Math Salon. My name is Dr. Nemendem. For those of you who are new to the Math Salon, know that the Math Salon initiative is there to help you grow in your mathematical skills, to help you improve in your mathematical skills. If you're in secondary school or high school, this is the place for you. So, today, in this video, I'll be trying to solve the questions that we had at the quiz last Sunday. This will be for the ordinary levels. A similar video will be coming for the advanced levels. It's important that before you watch this video, please go and watch the quiz video. Take the quiz yourself. Note down your answers. And after watching this video, you can correct them and evaluate your self-growth. It's important that you estimate after every quiz how much you now know compared to before the quiz. The solutions that I give here are not unique. They are not the only ones. There are several ways of arriving at the correct answer. That's the beauty of mathematics. However, the ones I choose to show you here are the ones that are intended to trigger some mathematical skills in you or rekindle them if you had forgotten. So let's look at this. The first question for that quiz says, given that L1 is a line that passes through the points, I just put the most important data from that question. So I do not rewrite the questions here. So it's important that you watch that video, please. So given that L1 passes through the points A with coordinates that and B coordinates this, and that it is perpendicular, and that it is perpendicular to L2 given by this equation here, y minus 4x plus 6 equal to 0. Find the product of the slopes of L1 and L2. In this question, the students could do it in a number of ways. You could decide, for example, to look for the slope between these 2 points, and then rearrange this so that it of the form y is equal to m1 x plus c1, or L2 for example there, y is equal to m2 x plus c2. So that then you can then multiply the two gradients that you would have obtained, or the slopes, and see the answer. But that was not my intention. I just wanted you here to remind yourself of the important properties of lines. If two lines of this form that we see are parallel, then this m1 and m2 that we call their slope or gradients would be the same. If they are perpendicular, then m1 times m2 will be equal to minus 1. It doesn't matter which equations of the lines. So the information I gave there was not important. It was just to like the aversion. The most important is for you to know that if two straight lines, we call them lines, are perpendicular to one another, then the product of their gradients or their slope is equal to minus 1. None of the answers was minus 1. That's why you have to choose E. We go to question number 2. This question has already been solved before in a previous quiz. I advise that you check the solution of that quiz. We will not repeat it here. But the most important concept there is that when you get something like this, you try to see if you can identify regular figures there. This looks like 1/4 of a circle. Actually, that's a sector of a circle with angle 90. So if I look for the area of this sector, and then I cut a triangle there, I look for the area of that triangle, I can subtract the area of this triangle from that of the sector to get this small part here. But this is only half of what I need, so I multiply by 2, and I get the answer. The answer was D. For question number 3, you are told if x is a real number, solve this equation for such x. There could be 1, 2, or 3 of them. Look at the video itself for the quiz and you'll see the complete question. But the important thing is that solve for x in this equation if x must be a real number. If a number is a real number, for example a, and you square it, it's always going to be positive. If I take another number b, which is also a real number, and I square it, it will always be positive. But if I sum these two squares and I get 0, then it means that is only possible if both of them are 0 at the same time. Because if this is 0 and this is not 0, then the sum will not be equal to 0. And if this is 0 and this is not, then the sum will not be equal to 0. So what we had to do here was apply the idea here. So that means here, if these two quadratic expression here sum to give 0, then it means each of the terms under must be 0. It means x squared minus 4x minus 5 must be 0, and at the same time x squared minus 3x plus 2 also 0. These are two quadratic equations for you to solve. You could use quadratic equation formula, you can use factorization, you can use all the tricks. Here, my coefficients of x here are 1, so I would just use factorization, it's easy. So, the factors of x squared, x and x here. Factors of minus 5. Choose the factors of minus 5 such that when you multiply them, you get the minus 5. When you sum them, you get minus 4. So, this is minus 5 here and 1. 1 times minus 5 is minus 5. 1 plus minus 5 is minus 4. So, I get two factors here. X minus 5, x plus 1. This is equal to 0, and for this one I do a similar thing. I get the x, I look for the factors of 2, which will give me minus 3 when I sum, so I have to think that it should have something to do with minus. So in this case, 2 and 1 are factors, but the sum will not be minus 3, so I take minus 2 and minus 1. I know if I multiply minus 1 and minus, it becomes plus. So minus 2 times minus 1 is plus 2, and if I sum, I get minus 3. So these are two factors as well. So this is equal to 0. That means x minus 5, x plus 1 is equal to 0. And the two factors from here, x minus 2, x minus 1 is also equal to 0. If I solve this out, I see that I get x here equal to 5 from there. Because if two numbers a multiply b give 0, it means either a is 0 or b is 0. That's the only way they can be. So they can both be 0 or one of them is 0. So this will be equal to 0 or this. If this is 0, then x equal to 5. If this has to be 0, then it has to be minus 1. And below, x here is equal to 2. And x here is equal to 1. If you check, you see that none of them are the same. For this to hold, we must get the same number, making this to be 0 and making this to be 0. From this expression, you don't have any. So the answer was A, 0. There is no such x which will be real for this equation to be valid. For question number 4 there, we have this trigonometric equation. So the most important thing was for you to look at the left hand side, play with it to get to the right hand side so you can identify what is B. So I try to force you to simplify this expression by making it look like this. So the most important thing was to look at the left hand side. If I see here, I get tangent here. But here I don't get that. So what do? You try to change your tangent to something like a sine and cosine, because that's a trigonometric identity that you know. So we know that the tangent of theta is equal to the sine of theta all over the cosine of theta. So if I replace tangent with that all through, I can simplify to most probably come up with an expression that does not have tangent, but has only sine and cosine. So I would fix this out there. So let's see, we'll make it neatly. So this is cosine here, theta. In the bracket, that is 2 plus sine theta divided by cosine theta. That's what we just agreed. Now we can replace this as sine theta and cos theta. 1 plus here, 2 sine theta divided by cosine theta. We can fix this a little more. So I have cosine theta here. These are two numbers that I have to sum up. They don't have the same denominator because this is over 1, this is over 1. But then it's easy because I can use the denominator as cosine theta. Since the easiest denominator you can use when you have to sum two fractions is to take the product of the denominators. So I can write here cosine theta as the denominator. Cosine theta divided by 1 is cosine theta. Times 2 is 2 cosine theta. Cosine theta divided by cosine theta is 1. 1 times sine theta is plus sine theta. I do a similar thing here. Also under its cosine theta. Cosine theta divided by 1 is cosine theta times 1 is cosine theta. Plus cosine theta divided by cosine theta is 1. 1 times 2 sine theta is 2 sine theta. This is a product, so I can actually cancel this with that. Then it makes my expression neater. There's 2 here, cosine theta plus sine theta times cosine theta plus 2 sine theta. All that divided by cosine theta. That's what I have here. I'm now left to expand this numerator. So I will take this and multiply this. take this and multiply that, and do the same thing here below. 2 cos theta times cos theta is 2 cos squared theta, plus 2 cos theta times 2 sin theta is 4 cos theta sin theta, plus, come now to this one, sin theta times cos theta is cosine theta sin theta. Sin theta times 2 sin theta is 2 sin squared theta, or that divided by cos theta. If I look at these two, they're exactly the same. 4 times here and 1 here, so they can just become 5. So this is here 2. I can factorize 2 because the same here. Cosine squared theta plus sine squared theta plus 5 cosine theta sine theta, or that divided by cosine theta. This is a fundamental trigonometric identity. Cosine squared theta plus sine squared theta is equal to 1. So I can change this to 1 and it becomes 2. And if I write this well, then this is 2 divided by cosine theta plus 5 cosine theta sine theta divided by cosine theta. The cosine theta cancel and I get exactly the form that I was expected to show. A divided by cosine theta and B sine theta, and B is 5. Therefore the answer was 5, and that was D.